character for processes like dyeing and painting. It can also improve the adhesion of coatings, adhesives, and other materials to the fabric surface for giving functional properties. Plasma technology can impart enhanced dyeing and printability, removal of surface hairiness, antimicrobial, and fire-resistant coatings. It is an environmentally friendly process. It can also be used for cleaning and even room temperature sterilization of medical textiles. In summary, plasma technology offers a versatile and environmentally friendly approach to enhancing a wide range of textile properties, making it a valuable tool for the textile industry. Dr. Shital's work on use of atmospheric cold plasma for processing of textiles is a marvelous approach to sustainable textile processing, the need of the hour. I appeal the industry leaders present here to encourage her in her presentation by being more interactive on her work and may also motivate taking her hard work to industrial application. And the young scientist deserves all the way to get your motivation and encouragement. With these observations, I leave the floor open to learned speaker and the participants. But before that, I would like to invite Professor Nian, the NIST's Women Power, and our executive committee member to formally introduce Dr. Shital Palaskar and conduct the proceedings of today's webinar. Thank you all.
Thank you,
Professor
Dr.
Nian.
Lal. Thank you, Dr. Lal. Now I have the pleasure of presenting a short brief on Dr. Shital Palaskar. So our esteemed speaker, Dr. Shital Subhash Palaskar, received her PhD Tech in Textiles from Institute of Chemical Technology, Matunga, Mumbai, and is currently working as a senior scientific officer at Bombay Textile Research Association, Mumbai. She has been trained for plasma treatments of nonwoven on different plasma systems at Textiles Technology, Nature and Technology Department, TO2C Laboratory, University College of Ghent, Belgium. She has also received the management training from Indian Institute of Management, Ahmedabad. Her research interests include sustainable processing of textiles, plasma surface modifications, plasma functionalization, nano finishing, functional finishing of textiles, and smart textiles. She has published more than 18 research papers in peer-reviewed international SCI or Scopus listed journals and 2 book chapters. So, Dr. Shital Palaskar, we are really eager to hear you. Welcome to the floor.
So with this, thank you all. And my sincere thanks to NISTI for giving me this platform to present the need of hour, which is already discussed. So here, and as Dr. Lal introduced that what is the plasma and all. So here with this, I would like to introduce our work. And in my today's talk, I will talk more about what we have done in Bitra for last 15 years and how that is going to be beneficial for today's requirement. That is when we see in today's environment, everybody is talking about the sustainability. So as we all know, the textile industry is already identified as the second largest polluting industry after agriculture. And therefore, there is a need of our to replace this conventional processing with the sustainable processing approach. With that, I will start my talk on atmospheric pressure cold plasma processing of textiles, a sustainable approach. So as Dr. Lal introduces rightly, that plasma is nothing but the 4th state of matter. And when we provide energy to the any phase, that is solid, liquid, or gas, the phase transition takes place. So when we provide energy to the gas, what happens is the gas molecules get dissociate into various energetic neutron, protons, ions, which have high energy, which is called energetic plasma. So these high energy items, neutron, protons, can interact with the textile material in various ways to clean the surface, to introduce the surface functionality, and make the fabric suitable for further processing. So plasma can interact with the textile material in two different ways, that is plasma etching and plasma polymerization. So when we use non-polymerizing gases such as helium, argon, nitrogen, etc., the plasma surface etching and plasma surface cleaning takes place. However, when we use polymerizing gases or some polymers, the thin layer of polymer get deposited, and depending on the function of that gas or of that polymer, the functionality gets introduced onto the surface. So I will not go into very detail of the classification of plasma and everything. I'll just introduce what is plasma and different sources of it. So plasma can be hot plasma and cold plasma, but hot plasma is not useful for textile as textile materials are very sensitive to the heat. So hence we use the cold plasma. Then again, the plasma is divided into two categories, that is low pressure plasma and atmospheric pressure plasma. The low pressure plasma is very good, find very good application in electronics and microelectronics. Whereas since we have very large volume to be treated in textile, so atmospheric pressure plasma is more preferred over the low pressure plasma in case of textile processing. So here are some of the example of plasma application areas. Like it can be used for creating hydrophilic finishing, hydrophobic finishing, oil repellent finishing, improving dyeing and printing of the textile materials. It can be used to improve the adhesion of the composite material. It can be also used for making the wool anti-felting, flame retardant finishes, and many others. So these are just advantages of few treatment of the textiles for removing the disguise, for removing the scales, everything. This we will discuss in detail, taking case studies, understanding the case studies. So these are some of the gases used in plasma for various applications like helium, nitrogen, argon can be used for making hydrophilic treatment. Argon oxygen can improve the adhesion properties of various materials and nitrogens. Of course, the carbon dioxide is also being used, but not in large quantities. So these are some of the non-textile applications. So it can be used in microelectronics, it can be used in automotive applications, in medical devices, and in general plastics also it can be utilized. So what are the advantages of plasma over the conventional wet finishing? So as we all aware, the conventional wet finishing is based on the water technology where the media of treatment is water. Whereas in case of plasma, the media of treatment is excited gas. So there is a very low requirement of water, or the water consumption is negligible. As we don't need to heat the large amount of water, therefore the energy consumption is very low. Another beauty of this treatment is this is a very surface specific treatment which does not affect the bulk properties, whereas in case of traditional processes the bulk properties gets affected, and in some cases the required bulk properties get deteriorated in a conventional process, whereas in case of plasma it is highly surface specific and we can tailor the surface as per our requirement. And we all know that this is an environmental friendly technology as it requires very less amount of energy, water, everything. So now we will see the case studies in detail one by one. So this is the schematic diagram of the plasma machine which we have in our lab. So it is basically work on the dielectric barrier discharge principle. So it is like there are two electrodes parallel to each other, and the electrical energy is provided to these electrodes, and whatever the gas is in between these electrodes get ionized due to the electrical energy and form the plasma. So whatever the material will pass through these two electrodes get treated with the plasma. So that is the dielectric barrier discharge principle, roll to roll system. Then this system have the facility to introduce various monomers in liquid forms, where we can introduce various monomers for functional finishings like hydrophobic, antimicrobial finishing, flame retardant finishing can be done in a dry environment using only plasma gases and monomers, etc. So the first case study I will talk about the hydrophilic finishing of the cotton and polyester fabric. So here we have treated the cotton polyester fabric using plasma technology with various powers and various treatment duration, and then the water absorption was checked with the wicking height measurement. So with the time respect, how much water can climb the height, so that it shows, and this graph shows the wicking height. We can clearly see that after plasma treatment, the treated samples absorb the more water and wicking height increase. So that shows that clearly the fiber becomes hydrophilic. So this small video shows the hydrophilic finishing of the polyester fabric. So this is the initial fabric and this is after plasma treatment. So you can see here the drops get absorbed very easily after plasma treatment. So once we do this plasma treatment, it can be further utilized for dyeing. So dyeing can be improved using this initial plasma treatment. Printing can be improved using this plasma treatment. And the beauty of this hydrophilic finishing is this is done in a dry environment. So only gases were used, no water, no chemicals were used for this. So the next is dyeability of the plasma treated material. Here I am presenting the results for nylon, but however, we have done this dyeability experiments after plasma treatment for various fabrics like cotton, polyester, silk, etc. Here the results are only for nylon. So if you see this, the dye bath color after dyeing after dyeing at 40 degrees centigrade for various duration, we can see that this lower is representing for the plasma treated one, the upper is representing for the untreated one. So in case of untreated, when you do the dyeing, the most of the dye remains in the dye solution itself, whereas after plasma treatment, the dye gets transferred onto the fabric and the solution becomes colorless. So in this case, we can say that after plasma treatment, the dye absorption increases. The same is shown through the graph also. And if maximum of the dye is transferred onto the fabric, the minimum is going into the effluent. So it can reduce the effluent load and reduce the environmental pollution. These are the SCM images. So after plasma treatment, the slight surface roughness is being created, which is mainly responsible for the improvement in dyeability of the material. So the next is the desizing of the gray cotton fabric. So here, when we do the desizing of the gray cotton fabric, we need to do it at a higher temperature and for a longer duration. Whereas when we do the plasma treatment, initially the layer of the size gets broken into a small parts, and it helps to reduce the, it helps to remove the size very easily. So here we can see that this is the SCM images of untreated gray cotton fabric, where we can see the size layer on the material, whereas after plasma treatment, this size layer or size film gets broken into a small pieces, and which actually help in removing the size or actually helps in desizing process. It makes very easy desizing. So the next case study is about the hydrophobic finishing of the cotton fabric using hexamethyl disiloxane monomer. So here, this is also a waterless process. This hydrophobic finishing was done using the plasma enhanced chemical vapor deposition process, where only a small amount of monomer was used. The monomer was used was HMDSO, that is hexamethyl disiloxane. And in this case, we have achieved very good hydrophobic finishing, which is around 135 degree of the contact angle. And here I will show you some videos for the water repellent finishing. that is a spray rating test, which is the requirement is around 90. So we meet those requirements. So here in the graph, here in the video, you can see the video. Just a minute. So here you can see the video for untreated and plasma treated material. For this is for untreated one, and this is for the treated one. You can see that the drops are rolling very well, whereas in this case the material is getting wet. And after this, the rating for this treated material is around 80. So which is very good water repellent properties. So here we can see that after plasma polymer deposition, a very small or very thin layer of the monomer is deposited, which is mainly responsible for this hydrophobic finishing. The next case study is about the anti-static finishing of the polypropylene fabric. As we all know, the static charge are very dangerous in the day-to-day application. So we need to have the anti-static finishing of this. So using plasma treatment, we have done the anti-static finishing of the polypropylene fabric, where we have achieved very good results. So here we can see that for the untreated material, the charge generated on the surface is very high, whereas after treatment, the charge generated is very low, which reduces the risk of static charge. And as we know, when there is a static charge, there can be a fire also. So we have mitigated all these causes using plasma technology and made the material anti-static, which gives a very good conductive results also. So fabric become conductive, and it won't allow the static charge to stay on it. It dissipates the charges as soon as possible within 5 seconds. So the fabric becomes anti-static. Another case study is about the development of multifunctional cotton fabric, where we all know that the UV rays are very dangerous for the skin and which can cause the premature aging of the skin. So in this multifunctional finish, we tried to combine the various finishes like UV protective finish, flame retardant finish, antibacterial, and crease resistance finish. So these 4 finishes are combined in one single fabric using plasma technology. And we have got a very good results for this. And for this, we have won the prestigious DST Lockheed Martin Innovation Award also. This is our patented technology. Another finish which we have developed is antimicrobial finishing using plasma technology. So here what we can see is when we use the plasma treatment, we can achieve a very good results. So in control, there is no reduction of the bacteria, whereas after plasma treatment, there is a very good reduction in bacteria, and which is quite durable to the washing also. So what we can say that after plasma treatment, the efficiency of the material to make it functional is improving, and it is also the durability of this functional finish is also improving after plasma treatment. So the next case study is about the adhesion improvement. Before going into that adhesion improvement, I would like to give a small introduction about the peel test. So this is the video about the peel test. I hope that everybody knows how the peel-off test is tested. So here the material is there. The gray is the base fabric, and the red color shows the coating layer. So it shows basically the force required to separate the coating layer from the base material, and this is the force required is plotted against the time elongation. So this is the adhesion test. So the next case study we have done about the adhesion improvement of the coated fabric after plasma treatment. So here we can see this lower side, The black line represents the adhesion properties of the untreated material. This is on the polypropylene fabric. Similarly, we have studied this on the polyester and nylon fabric also. And what we found that there is a more than 500% increase in adhesion properties. So it clearly shows that after plasma treatment, the life of the coated fabric is improved and the separation of the coating layer from the material can be prevented using plasma surface modification technology. So the basic reason behind this is here we can see that the untreated material has a plain surface, whereas after plasma treatment, surface become rough. So this rough surface is basically acting as a locking side or mechanical interlocking happens after with this rough surface. So here we can see that for the untreated, the coating layer is clearly separated. The separation or this gap is clearly seen. Whereas after plasma treatment, there is no gap. So we can say that after plasma treatment, the coating layers stick very well to the base material, which is the reason the life of the coated material gets increased. Then the another finishing or another case study we have done on the durability improvement for the conductive fabric materials. So here we have done the deposition of the conductive polymers on the cotton fabric. Initially, the plasma treatment was done, and after that, the conductive polymer was deposited, and the durability was checked to the repeated number of abrasion cycles. So here we can see that this is the untreated one. After the 1,000 number of abrasion cycles, the conductive coating gets removed. However, for the untreated material, however, for the plasma treated material, the coating of the conductive material remains there. So it shows that after plasma treatment, the adhesion of the conductive coating is improved, and which is mainly responsible for the durable functional finishing. So with this, this is all about the experimental studies. Now, this is one of the case study I have taken from the published literature, which talks about the life cycle analysis of the plasma treated materials and the saving in the energy and the environmental benefits. So this study is done for the polyester hydrophobic finishing of the polyester fabric, and it is compared with the conventional wet processing. So here we can see the energy required for making the same kind of hydrophobic finishing in a conventional method and in a plasma method. So here the energy requirement is very, very high. Whereas after plasma treatment, if you do the same finishing using plasma treatment, almost 70% of the energy can be saved and 85% of the water can be saved. Similarly, if you see the emission in the water and air, it can reduce almost in the range of 70 to 80% water and air emissions. So we can say that with this plasma technology, it is very, very environmental friendly technology. Then these are some of the industries which are using plasma technology commercially. Unfortunately, these are all international industries which are using plasma commercially. So here the Sati, which is using the plasma technology for treating the screen mesh and for treating the filter fabric, which is being used in automotive applications. Then there's a P2I is a very well known in UK based industry which are using plasma technology for treating full garments to make it waterproof. It is using the plasma technology to make the electronics also waterproof. Sometimes you have seen the advertisement of some mobiles which falls into the water and nothing happens. That is because of the plasma coating of those electronic material with the hydrophobic finishes. So the layer of this hydrophobic finish is very, very thin. So that won't affect the performance of any electronic material or any textile material, but it gives the waterproof conditions, which is protecting it from the water. So such kind of applications are there. So one more interesting applications which is done by the Japanese companies for the sports equipments, which can improve the utility and the durable life of the sports equipments. Then there is SKZ Plastic Industries, which are using this plasma technology for ultra fine surface cleaning, which improves their further adhesion properties. Currently, we are working with some Indian industries for the plasma treatment. For various functional finishing, they have also shown very keen interest for the plasma technology, and we are actively working with them. So with this, we have got some recognition. We have recently we have got the Advanced Material Young Scientist Medal Award from the International Advanced Material Sweden. Then we have got the DST Lockheed Martin Innovation Award for our multifunctional finishing fabric. Then we have patented our technology, flame retardant finishing of the textiles using plasma technology. This patent is for flame retardant finishing. The another patent is for multifunctional finishing of cotton fabric. With this, we have various projects from the government of textile, Ministry of Textile, Government of India. So currently we are working on the scale up of this plasma technology, because in last few years we have got many inquiries to make this technology commercial. So we have got very good project where we are planning to have the industrial scale demonstration plant to set up in Bitra to show the feasibility of this plasma technology for Indian textile industries. Then there is another current project is going on for the from the ministry from the DRDO, Ministry of Defense, for development of anti-static polypropylene fabric, and the few more projects we have already completed using plasma technology. These are the 2 books we have published, and these are some of the publications which we have published in peer-reviewed journal, high impact factor. And lastly, I would like to acknowledge Professor N.V. Bhatt, who has given this idea for the plasma treatment. And we have started this work in 2009 with his guidance. Then the earlier director of Bitra, Dr. Desai, he has supported in initial starting of this project, and the current director Bitra, and of course the NISTI and all the organizers and all the participants. I would like to thank for their attention and their time. Thank you.
Wonderful, Dr. Shital. You have presented very well in time.
Yes, thank you,
This is
sir.
the record. She has beaten the record of NISTI.
Yes, wonderful,
Ah,
wonderful, Dr. Shital
wonderful,
Palaskar.
wonderful.
Wonderful.
Everything crisp and complete. Nothing she has left, and completed it very well in time.
Right. So, Dr. Palaskar, if you are a little
Yes.
rested, if you want to catch your breath, you will wait for a while. But in the meantime, I do want to inform you there are few questions which I will read out to you as you go along. And I also invite all the participants to put in more questions either in the chat box, or you can raise your hands. We'll come to you once we finish the initial questions. So, Dr. Shital, if you are ready,
Yes.
I can put the questions to you.
Yes, sir,
All right.
sure. Sure, ma'am.
Okay. So we have a question from Mr. Ravi Shankar Gopal. He would like you to please elaborate on washing fastness of nylon fabric dyed with and without plasma treatment.
Okay, so this we have done the dyeing study. So once the dyeing is done, the dye is fixed on the fabric. So it is equal to the untreated one, or it is sometimes it is a better half degree. We have found the improvement in half degree. Like when we get the wash this color fastness to washing rating 4 to 5 for untreated one, we get the same 5 rating for the treated one. So once it is fixed on the surface, it won't come out after plasma treatment.
Mm-hmm. Okay, it is followed by another question from Mr. Gopal. In PP material, is there any loss in strength due to plasma etching?
No, we didn't found any loss in plasma after plasma etching, but interestingly, we found the increase in strength because what happens, the surface of this PP is very smooth. So when we separate it through the tensile strength, the fiber slides very easily and gets separated. But when the surface etching happens, the cohesive force on the fibers get applied, and that's why it shows the increase in tensile strength rather than decrease.
Right. So, Mr. Gopal, I know you have one more related question. Would you like to put on your audio and ask Dr. Shital Palaskar? Are you present? I'm sorry, I can't seem to see you. But could you ask the question? Okay, maybe I'll read it out to you. Another question is, can we improve adhesion between nitrile rubber and nylon and polyester fabric? Has there been any trials taken by you?
We have taken the trials on nylon, polyester, polypropylene using polyurethane, but nitrile also we can do. We have not done that study yet, but there is reported literature which talks about the improvement in adhesion.
Right. All right. And okay, I'd like to invite Mr. Shailesh Kaushik to ask your questions. There you have quite a few questions to go through. Would you like to please put on your audio and ask the questions?
Yes. First of all, I would like to congratulate Dr. Shital for taking up this complex topic and yet presenting it in very lucid, simple, and in a manner which everybody can understand. My question is about composites. You talked about composite etching. So I have an application where I'm using multi-polymer braid over a rebar, and that ultimately will find place in concrete columns and beams and etc. So I want to improve the adhesion of the braid, which is out on the outer periphery, with the concrete or the cement. So will this plasma treatment will help in that scenario in any way?
So there is a reported literature which talks about the pull-out strength improvement for the concrete materials with the fibers. But we have to see what material you have and how it is going to be interact with the plasma.
Because what I have used, the materials I have used are polyester, nylon, ultra high molecular weight polyethylene, which by the way is very slippery, and basalt.
Right.
So these are
Yes.
the 3-4 polymers which I have used.
Yes, sir. In that case, it is very much possible to increase the adhesion strength and improve the
And
composite.
the etching you think is the better method?
Yes. So
Okay.
in case,
Yeah, please carry on.
yes, sir, in case of adhesion improvement, there are mechanical as well as the chemical theories. They are working together. So more. It depends on case to case. Either the chemical theory will be dominant or the mechanical theory will be dominant. But in most of the cases, we have seen that the mechanical adhesion improvement theory is dominant.
Okay. Thank you very much.
Okay, and may I invite Dr. Kothari to please unmute? And please go ahead and ask your question.
Okay, thank you, Dr. Seetal, for very nice presentation. It was nice to hear from you on this particular technology. The technology has been in existence for a very long time, more than say
Yes, sir.
35 years I know of, because
Yes,
I
sir.
first saw this technology 35 years back in Italy, where same things were being done, and somehow commercially it has not caught on. Any reason for not being successful commercially with textile materials as such?
Sir, see, the commercial, the few name I have presented in my
There's
presentation,
no
the few
Indian company using it
there
so
is
far.
there is no Indian company using it so far. The reason being, the whatever the machine which India is having or being manufactured in India, they are not competent yet that they can give the required result. And
No, but we
second
don't
thing,
have to rely on the Indian machines. We don't have to, matlab, if
yes,
some
yes, sir. I'm
Hmm,
coming to that
yeah,
point
yeah.
also.
Hmm.
The second thing is whatever the machinery is available, most of the Europeans are there who are manufacturing world-class plasma machine, but the cost is one of the factor. And in Indian scenario, the manufacturer or the owner of the industry is firstly asking the increase in the cost. So they are not looking the indirect benefits which we are getting through sustainability or through saving the chemicals, but they are asking directly the cost factor involved and the payback period. So there the Indian industry is lacking behind, and they are not coming forward to take this technology industrially.
No, but apart from Indian industry, the other industries are also not the textile industry I'm talking about in
Huh?
particular. They are not really caught on because the number of manufacturers of machines also are very limited, matlab ye, for plasma treatment.
Yes,
Is this
yes,
true?
yes, sir. Yes, that's true, sir.
Let's hope that the things changes. Because ultimately the people will look at the cost advantage if it gives, and there are so many benefits you say can be derived, and these benefits have been known for quite some time, but somehow what has happened is nothing has really happened commercially. So
No,
let's hope things change for
no,
the
sir.
better.
Now onwards, I'm really hopeful that it will happen because now, until now, the sustainability was choice, but now it is not choice, but it is the requirement of our. So hopefully, in few years or in coming decades, the Indian scenario will change and they will come forward to accept this technology.
And is the machine very complicated? Because the way the technology has been described, the machine
Huh.
should be pretty simple.
Yes, a machine is pretty simple to handle. But it has some complex, not complex, but needs a proper study, like for what application, what gas to be used, up to what level it should be used. So that basic study is required. So that's why it is little complicated, we may say, but it is not complicated at all.
In fact,
Okay,
closed
thank
chamber
you.
it should be. It should be in closed chamber, plasma generation as well as treatment. That is not that has not become possible so far. Plasma creation, plasma generation, and the treatment on the fabric. That should be in closed, totally closed chamber.
Mm.
Shital, I have Ravi Shankar here. I just want to ask one more question. So
Huh.
the one of the if the process is so simple, and why is the machine so expensive as you say? It should not be.
Yeah.
This is number one. Number two is this. I've asked the same question. For this technology, whether I should use argon or whether I should use CO2 or whether I should use helium for a particular property to be obtained, somehow the process knowledge is not there. That is why the industry is not using. Industry is not going to do R&D. R&D has to be done by R&D people, and a ready machine has to be provided. I think that is not available as of today. As you yourself said, it is complicated, it is not so easy and all those things. So I think once this technology is known to everybody and the processes are finalized for a particular property on a particular fabric, then only it will become commercially a success, as Mr. Kothari was asking. So I think that is the area you must work on. And
Yes, sir.
yeah.
Right. There's a question by Mr. Karthik Samanta.
Thank you, madam, and thank you sincerely, Dr. Shital, for the wonderful presentation. We have covered almost all the finishing of textile using the plasma technology. This is a wonderful talk. Just, madam, I want to know whatever finishing you have showed during your deliberation, whether all this carried out in under atmospheric pressure plasma condition or some of them in vacuum plasma.
No, all are carried out in atmospheric pressure plasma.
Okay. And just one more thing, what Professor Kothari was asking regarding the commercialization aspect. You know that plasma in processing thickness of the fabric matter a lot when we talk about the
Yes.
atmospheric pressure plasma.
Yes.
So
Yes.
what is the present status? It may be national scenario or maybe international scenario. How much thicker fabric till date we can process in atmospheric condition? Because we have a lot of fabric, silk, we have a cotton, we have a jute, we have a felt, non-woven. So what is the international scenario presently in highest thickness or GSM of the fabric we can process safely in atmospheric condition?
And sir, again, it depends on a technology. Like if you consider the dielectric barrier discharge atmospheric pressure plasma, in that case, as you increase the gap between the electrodes, your plasma becomes non-uniform.
Right.
But if you go the glow plasma, which is again an atmospheric pressure plasma, the glow discharge, in that case, this gap is not an issue. So it depends on what technology you are using. So, but when you consider the textile processing, the dielectric barrier discharge is most suitable since it is
Right.
cost effective.
Right.
But in that case, the thickness is the limitation, as you likely said.
Right.
So as such, there is no any particular literature reported or patent status. But
Okay.
as per our information or as per our experience, we can say that we could process the material which is having a 1 or 2 mm thickness. More than that, it becomes difficult.
Whatever you have mentioned, that cotton, silk, nylon kind of things, what is the maximum GSM or maybe thickness of the material?
Sir, whatever the results I have presented for all the fabrics, they are in the range of 100 to 300 GSM.
Okay. Okay. Thank you, madam. This is a very nice and informative talk. Thanks. Thank you, madam.
Thank you. Thank you. I just want to take a minute to announce that we have Dr. A.N. Desai with us on this webinar, and he, under his guidance, correct, Dr. Shital Palaskar, that
Yes.
that it was under his guidance that this project, this presentation has been undertaken, and we would really like to, sir, can you switch on your, would you like to say a few words, sir? Do you? Yes, Dr. Desai. Can you hear us? Dr. Yadav, would you see whether he's unmuted?
Yeah, Dr. Ashok Desai is there and he has been unmuted in case he want to.
Would you like to say a few words, sir?
Yeah, am I audible?
Yes.
Yeah. Commercialization aspect was talked just a few minutes back. The point here is, one is, of course, as you people discussed about the capital cost investment. The other is, during my tenure, we tried to do this, implement this in certain industries. The first question I was always asked was, anybody doing it in India? No, sir. Then let somebody use it, then I will use it. That is the problem. And when they go abroad and see something, then they come here and ask, oh, this kind of research is not done here. That I'm sorry, pardon me if I am a bit frank. That is one part of it. The other is, it is extensively used in certain specialty applications abroad, as Shital displayed it on the screen. It is not, although the technology is old, more than 10 years back, maybe 15 years, P2I was doing these samples commercially for certain specific medical applications, which I had collected the samples also when I brought it back. That is a kind of thing that is being done. And many more process houses abroad, we don't know if they are using it. Normally, process houses are kept confidential. I don't know really who is using, who is not using. Even in India, people say, yeah, hamara secret hai and all that. That we don't know really. The other part is a couple of points which I wanted to emphasize. When the dye affinity has increased of plasma, the dye stuff requirement is also required to be less. Although there are no quantifications for this has been reported in the literature. As far as the concrete adhesion with plasma, maybe more than 10 years back, there is sufficient literature on this. In fact, that was supposed to be worked out, but then for some reason we could not continue. One more thing that perhaps is important is water repellents finish. I am told, I'm not a chemist, but chemicals used for water repellency are harmful right now in the conventional process. And here, what they're using monomers in small quantities, maybe a few cc's. And that itself is another positive aspect of plasma technology. These kind of things are there. And only one small doubt is still there in my mind, which Shital perhaps can clarify. After plasma treatment, how long can you keep it? Durability of the treatment itself. Suppose you take it for dyeing after some time. Suppose you do plasma treatment today and tomorrow you take it for dyeing, or day after tomorrow. How much time that plasma treatment durability is there? I think something was being done those days at Bitra. Now I am not able to recall also that. Thank you, madam, for this.
Yes.
Thank you, Dr. Desai. I have a few more questions to go through, Shital, if you're okay with that.
Yes,
Mr. Avijit Kumar Roy, can this technology be used to enhance the strength of the fabric like Kevlar? So that's the question from Mr. Roy. Yeah.
Yes, it can be utilized, used to enhance the strength of Kevlar or some specialty materials. Like as we have seen in case of polypropylene or those fibers which are having the inherently smooth surface. In that case, of course, it is very much useful to increase the strength of the materials.
Right. Mr. Sandeep Kaswan has a question for you. Can you explain about chemical assisted plasma treatment for hydrophobic and flame retardant? What stage these chemicals are added?
Okay, so as I have shown the schematic of this machine, there is a provision to introduce the monomer in vapor phase. So that is called plasma enhanced chemical vapor deposition. So we introduce the monomers in a vapor form, which gets deposited onto the surface via plasma chemistry. So when it mixes with the plasma, the vapor of those chemical or vapor of those monomers get mixed with the plasma. It forms a polymer, or it gets deposited on the surface, which basically responsible to give that functional finish, like water repellent, antimicrobial, flame retardant, and many others.
Right. Thank you. And there's a question from Somen Saha. What would be the average cost of dyeing per kg of cotton? Would you be able to, or anyone else as well? Would you know, Shital?
In this case, we have not calculated the particular cost per kg, but we have calculated the saving in water, the saving in energy, and saving in time. So what we can say is 20% of the dyes can be saved. The time can be reduced from 1 hour of the actual dyeing to the 45 minutes. So 15 minutes dyeing cycle can be reduced. And there is a saving in energy. So we can do the dyeing at little lower temperature, say 80 degrees or 75 degrees centigrade. So that kind of saving is there, but that actually we have not calculated in terms of rupees per kg or or the
Mhm.
cost per kg.
Okay.
That
All
needs to be
right.
calculated.
Nian, I just wanted
Yes.
to, this is
Yes,
Ravi
please,
Shankar.
please.
I wanted to add one more thing.
Yes.
The important thing for any machine to be a success in any new processes is the machine supplier should know the process very well. You see how Reiter is supplying spinning machines because they know the process very well. Why Reifenhauser is selling their spun bond machines? That is because they know the process very well. They can tell the customer, this is how it should be done for this. So that is when the machine will sell. You cannot have just a machine and then let the customer do the experimentation. He's not going to spend money, do the R&D after buying the machine. So I think that is where the whole system is lacking. That's why this plasma, the machine, whoever is making the machines are not able to provide the technology to the buyer of the machine to make his product a success. I think this is where this is not working. As Ashok Desai said, is 35 years people have been trying, nothing has happened. Only a few people have mastered it, and they are doing it for a special purpose, and they're getting their value. If it has to be a commercially a success and used in bulk quantities, I think the machine maker should understand this technology and provide technology to the buyer of the machine. I think that is the point I wanted to say.
Right.
Second, Shital has to clearly see machines in a textile mill work at 50 meters per minute, 100 meters per minute, 40 meters per minute. Whether the plasma can be carried out at those commercial speeds. What you are doing in the laboratory is all at a very practical 1 meter, 2 meter, 3 meters. So that is not going to help the industry. This is my point. She can clarify on that.
Yes, sir. Exactly true. The machines which are newly developed, they are coming with such a high speed which can match with the commercial speed of the conventional machines like 50 meters, 80 meters per minute. The first point which you have mentioned that the manufacturer of this machine should have come up with, they should have the technology, they should know the process. In that case, it is very difficult for the manufacturer to understand the textile processes and develop the machine or develop the technology accordingly. But what the new machines having the feature is, they can the user can save the recipe, the result of that recipe, and depending if they want to repeat the same result, they can recall that particular recipe and run the machine accordingly. So such kind of developments are there. But of course, it is very difficult for the machine manufacturer to master that technology for textiles. Because this plasma machines, apart from the textile application, they are being used for various other industries also. So I would means it will be quite difficult for the manufacturers.
No, it is. I tend to disagree because if you see any big manufacturers, you take any textile machinery manufacturers, they all take a small. You can always run. They have a pilot plant. You can run a small production lot, even up to 1 ton in many cases in Germany and the US, and then you can make your product, bring it back, test it, and then buy the machine. That should be that is the only way to sell machine to the textile industry for them who don't know the process, who don't know the technology.
Yes,
Nobody is going
yes,
to.
many of the manufacturers, they are doing this facility. Even in fact, we have also used such kind of facilities before finalizing the machine to buy it. So they have given all the possible response or possible support from their side.
Okay, but nobody has bought in India. That is why I'm saying.
I think we'll have to wait for a long time for that, perhaps very soon. Can I continue with the other questions? There are a few of them still. So Mr. Avijit Roy has a question. Have you tested it on carbon fiber? Has this been tested on carbon fiber?
No, right. Till date, we have not tried on carbon fibers.
All right. Okay, the next question is from Dr. Surendra Kumar. What is the effect of plasma etching on the strength of the cotton fiber?
So it is on very nano level etching. So it is not degrading any kind of tensile properties.
Right.
So we have not seen any change in tensile property of cotton fabric.
Right. Okay, sorry. I'm trying to see.
Salil Chawla has raised hand for a long time. He is.
Yes. Okay. Please, Mr. Chawla.
Yeah, very good evening to all, and
Yes.
for giving me the opportunity. And I am really, it was like a music to the ears that sustainability is a business imperative, because especially in the given context when we are a highly polluting industry, second only next to, oil industry. So, given that, for me, this is not a question, it's a plead actually. I would plead. First, I want to compliment Dr. Sangeeta, Dr.
Shital.
That she made a great presentation, because subject like this, complicated subjects like this, it was not easy to, put across in such an inspiring and lucid way. Great presentation, ma'am. Please accept my that congratulations. The
Thank you, sir.
plate is that we are one of the oldest publication. I'm director of DFU publication. Since last 36 grand years, we are in the service of the trade, and we are a complete magazine, and we have got 3 web portals also in our portal. The question is that I wanted that if you could send us a synopsis, something within 300 to 400 words of this presentation, we'll love to publish it alongside giving you due credit, to
Great,
your,
great.
so
Great.
that we
Great,
can
sir.
put it across to the trade. Idea is that it should go length, This should not
Yes.
restrict to only your members and attendees. It should go across the whole universe. That's my plea, and that's my humble request. Thank you so much.
Salil,
Yes, sir, sure.
give
Thank you.
credit to Nishti also in that your publication.
Yes, sir. Why not?
She
Why
said.
not? That is a
All
due,
right.
sir. Dr.
So-
Lal, thank you.
Thank you, Mr. Chawla. I think I'm
Thank you,
sure
ma'am.
Shital and you can have a chat beyond this.
Thank you.
There's a question from Rohit Kapoor. How far are we from the commercialization of plasma treatment of cotton gray fabric? I would think that perhaps this has been addressed. Or would you like to delve on it a little more?
Sir, see, as I have shown in my presentation, this all the finishes or all the treatments with the plasma have shown very good results, which is already proven. So it is just a matter of time when industry will come forward and take it for the commercialization. So
Right.
I hope soon it will happen.
Right. So there are 2 questions on dyeability, one by Sachin Kumar and Vaibhav Chauhan. Why dyeability of nylon improves with plasma treatment? And does it have effect on the dyeability of fibers which cannot be dyed, like peroxidized PAN fibers and Kevlar fibers?
Yes. When we do the dyeing of the nylon fabric, there are 2 factors. The one is the surface etching, which can make the fiber more accessible for the dye, and it accepts the dye easily. The another thing is it creates the functional groups, which helps to create the bond with the dyes. So these are 2 functions with the nylon dyes. And the second question which you have asked is about the fibers which cannot be dyed in a normal process. Yes, the polypropylene is very well known for the difficult to dye by exhaust method. Of course, it is being dyed by dope dyeing, but we have done the dyeing of polypropylene by exhaust dyeing method using plasma surface modification. So what we have done the plasma treatment of the polypropylene fabric, made it hydrophilic. We have created some functional group, and then we have dyed with the acid dyes, which were taking very good acid dyes. So similarly, we can try on Kevlar fibers also. But since the Kevlar is very well known for its functional things rather than its look, so it is not been done yet. But of course, we can try on it also.
All right. Shital, at this rate, some more to go. So I'm sure you're going to. This is quite a different question. Can this technology be used to make the standard plywood into a waterproof plywood?
Yes, 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 it can be done. Since we are we are dealing with the textiles, we have not done this kind of studies, but it can be done very easily.
So, Mr. Roy, I think you might like to start off with this experimentation if it is possible. Okay, Vaibhav Chauhan, does it have any effect on the durability of the finishes and dyes also?
Yes, so mostly when we talk about the plasma treatment, the durability is always a question. But if you see after most of the treatments are for the further improvement of the process. Like when we do the hydrophilic finishing, it is for the improvement of dyeability or the improvement of printing or the improvement of adhesion property. So when after doing the plasma treatment, we have to complete the further process within given particular time. Once that is done, whatever the improvement is there, like improvement in dyeability or improvement in adhesion, it will be there for lifelong.
All right. So thank you, Shital, so much. With your permission, can I put in a question for Dr. Desai? There's a question for Dr. Desai. Is that fine?
Yeah, fine.
All right. So we have products like Gore-Tex, which use harmful chemicals. Can that functionality be achieved with plasma without harmful chemicals?
I think Shital showed the DSMO. Am I right? I'm sorry, I forgot that. These monomers are used for that, wherein the effect is hard. They use only in very small, minute quantities and vapor deposition. That is what she was explaining. That is how it is used. In large quantities, these harmful chemicals are not to be used. But I take this opportunity, madam, to also clarify another point of Mr. Ravishankar, an old friend of mine. So he was telling that example of ring spinning. For that matter, most of our spinning or weaving processes are well known for not decades, centuries. So there is no question of something new coming up there and training and giving the technology. Anything new comes up, the machinery manufacturer generally helps. Even in this case, they have helped us also, and they are prepared to help the commercial users. And I am telling you this because we ourselves have asked about this. A new technology, somebody has to help the user. And that is possible by the manufacturer, and he is doing that. And to the best of our knowledge, at least a couple of them from Europe. And that is not going to be a problem for usage in India, definitely. The other point is about the cost. Once our own electrode in that machine long back, it failed and we had to import it. It is most expensive part of the machine is that which gives you the plasma treatment. And that was very expensive for a research organization. Definitely in wide width machines, it will be much more expensive for industry. And I am also told, in fact, I visited what is that Plasma Institute in Ahmedabad. And they also were telling the same thing when we visited long back. They tried to make wide width plasma machines for textile applications. To this day, I have not seen any commercial machine of that kind. So these are the problems of introducing, not necessarily the ignorance of the technology, or the technology provider is there and research institutes. In fact, I remember having same problems somewhere in the early 80s when we introduced nano-ovens. That time there was hardly anything nano-ovens in India, except in one in Rajasthan with second-hand machines, probably. And then now you see, you yourself know how much nano-oven industry has grown. Those days also we were trying to introduce that with similar thing, but then the machinery manufacturer helped them. That is how it is, and we were there to give supporting systems. So that is how any new technology is going to be like that.
Okay.
Thank you.
Thank you, Dr. Desai. May I invite Dr. Kuldeep Sharma to please ask your question?
Thank you, the speaker Shital, Dr. Shital. It has been a very comprehensive presentation, and hard work on the issues related to textiles are much appreciated here. My query is not a query to her only, but it is a query to us as well as a industry association assisting the industry, academia, and research together to maximize the benefits for the application, the research done in TRAs and other. My due apologies to my friend who is present from TRA, Dr. Ashok Desai, and likes of him also in the industry. The simple thing is that we can't undermine the diagnosis and analysis of Ravi Gopal, Mr. Ravi Gopal and Dr. Kothari here. That 35 years of inception of this technology, we are still in the same nascent stage nowhere. It poses a question to us that in other areas we have been adopting technology. Once we talk of technology, any machinery related to the new technology is going to be expensive for anyone, not for the general industry, but for early birds are always there in the industry to take forward the new technology. We still have potential in our corporates to take ahead this. So my query, which is addressed to me and my colleague chairman here, that it appears that the policy is made at research institutions. It's very good, appears very good. So 18 papers, research papers published, and so in so many journals, so many books written, so many credentials in research institutions. But why can't we think of a system in which the testimonials from the industry for the research done by the institutions are made possible on the platform, general platform, or to the policymakers, and then go ahead. That would, my only consideration at this point is that will make research institution and industry both sensitive on the issue and go hand in hand in adopting that technology with the application purposes and commercialization. We simply can't blame anyone that 35 years of research done on this and 10 or 11 European manufacturers already into this field. And we are still lagging behind where we to boast in terms of technology in various other domains also. So please let us move it on the platform and think and submit some policy matter to the government through our platform here and with industry together to think so that this benefit can be percolated speedily in the industry. Thank you very much.
I would like to clarify in this
Yes, Dr.
matter that government has been doing their effort, and Dr. Desai will also agree that during Jain Singh's times, we had helped Bitra to procure some machine. There are certain technologies which are coming with the challenges, like say it is not only this plasma technology, this liquid carbon dioxide dyeing also had so many challenges, and it is also maybe more than 35 years. Dr. Kothari says this technology of plasma research is going on over 35 years. But this liquid carbon dioxide research has been going on for a long time, still more than that. But now it has become commercial. So the industry forces have to realize and believe the benefits of that. And it is not that government makes a policy. How much government cannot run the industry? Industry has to come forward. And government has tried. See, Dr. Desai is there, Shital is also there. They know that industry partnership has been made compulsory on some of the projects of these textile research association, so that industry feels it and takes the technology to their shop floor level. Anyway, this is all the matter of discussion and matter of debate. The technology is there. it has been well researched by Dr. Shital, and I am very happy that she has faced all the questions very confidently. She has not blinked a minute, blinked a second also to reply any question. That way, I congratulate her and wish that she has a very bright future. The young lady, young girl, I should say, not lady, a young girl.
Very
She
true.
has
Very true.
she has a
Yes,
good
sir.
future, and I
Right.
am thankful to Dr. Desai, who has suggested that her projectors should be facilitated on NISTI platform, and our mission is also there to mentor young scientists.
Right.
So
I'm sorry,
So,
Dr.
Can
Shital.
I just, Mr. Roy's hand has been raised for a long time. Can I invite him, please, to ask your
But
question?
let me
Unmute yourself, sir.
finish.
Madam,
Let me finish in few seconds. I should say that this has been one of the best presentation because so much interaction has taken place. I have seen during my tenure, never in any webinar, either it was beyond schedule, that is why so much interaction was not taken. She has been perfect in maintaining schedule. And then so much interaction has taken place. I am very happy. And the audience also have joined in very large number. I think presents went beyond 75. So thank you, Dr. Shital. Thank you, Dr. Sai. And we are very thankful to you for giving a good presentation to NISTI audience. Thank you, Dr. Shital.
In a lighter vein, Dr. Shital, I am sorry that you faced so many questions, much more than you have faced during defending your PhD thesis.
Rightly, sir, rightly.
Sorry, Shital, just one more question before we go on to winding up. Can I invite Dr. Roy, Mr. Roy, to please ask your question?
yeah, good evening, madam, and the team. It was a very wonderful and insightful session. I would like just want to put in some input that electricity being so essential nowadays, it also took a decades to transfer from Faraday to Edison. And it is not only the technology's benefit, or it is a number of parameters which contribute to success of any technology. This technology has immense potential, and I don't know, as you, ma'am, jokingly said that you should take it into plywood. It might be a real thing that it will be a very good application in the plywood or even any other industry also. Technology has is like water; it can flow to any application, and I see a huge potential to this technology. Thank you, madam.
Thank you, Mr. Roy.
Thank you for you.
Sorry, there is one more question. Should we take it or not? Shital,
Now
who
invite
decides?
Mr. Vajpayee to say about
if time permits, we can take it. No issue.
Sir, madam, please finish in time.
Take the last question.
Let this be the last one.
So,
So, Mr. Vaibhav Chauhan, if you can put on your, if you can unmute yourself, you may ask the question. Can we help Mr. Chauhan to unmute?
Yeah, it's done. Okay. Thank you so
All
much. For me, my question is very simple. I just wanted to know for how much time duration we can hold the fabric after plasma treatment so that we move to the next process. Like if we have to go for the dyeing, if we have done this today for 24 hours, we can keep the fabric, or for only 1 hour, we have to keep the fabric. Is there any time durability related to the process?
Yes, sir. Yes, sir. That study we have done. And ideally, it should be done on the same day. But if it is not possible, you can wait for 24 hours. Even if you wait for, say, 1 week, maybe 5 to 6 days, then also there will not be any significant difference. So ideally, it should be done as soon as possible. But you can wait 2, 3 to 4 days. There's no issue.
Before we go to vote of thanks, I would like Shital to say a few words about NISTI and today's experience. Very briefly.
So first of all, I would like to thank NISTI for such a wonderful platform and connecting me with so many industrial peoples and distributing my knowledge and sharing my knowledge and distributing my research with them. So I'm really thankful to NISTI and all the organizers and all who present here and for their time. I'm really thankful to them. Then about the NISTI, of course, it is very good platform to make the technologies or to share some good knowledge with the industries so that the industry people will be aware what is happening in the research. And of course, the research people will also understand what is actually the requirement of the industry. So, it will really help for the research people also to understand the current requirement of the industry and work in requirements of them, so that the industry will get the good output from the research. And of course, the technologies or the research will see the industry or commercialization. So I'm really thankful to the NISTI, and NISTI is really doing good effort to make the technology commercial or to make the research commercial.
Thank you,
Shital,
Dr.
it is a good
Shital.
Thank you,
certificate to us.
Shital. Thank
And
you
a
for speaking
brief-
from your heart.
And a brief announcement, the next webinar is going to be one by Professor Mangala Joshi of IIT and another former Additional Textiles Commissioner. So please be tuned to NISTI and we will get you informed about the date and time. Now, I think Mr. Bajpayee.
Thank you, Dr. Rana. May I invite Mr. Bajpayee to give the vote of thanks?
Thank you, madam. Thank you. This was the fantastic presentation. Thank you, Dr. Shital, for this wonderful insight, sharing the knowledge. Your Dr. Shital shared valuable insights on the today's webinar. Your contribution enriched our knowledge. Thanks, Dr. Lal, NISTI Chairman. Dr. Lal is always taking pain to arrange such seminars and webinars on the NISTI platform. I am also thankful to Dr. Vijay Yadav, Secretary NISTI, for his help and support. Thank you, Professor Nian, for such wonderful moderation and seamlessly facilitating the discussion. Thanks our esteemed participant, Professor Kothari, Professor Sanbag, Dr. Kuldeep Sharma, Dr. Ashok Desai, Dr. Ravi Kumar. Thank you. Thanks to our all participants for their engagement and thoughtful queries. I'm also grateful to wrap up this event. I look forward that we will meet again in the webinar by Dr. Mangala Joshi and Mr. Burma, Additional Textile Commissioner, as announced by our NISTI Chairman. Thank you all for joining us. Thanks.
Thank you. Dr. Shital, I have one last question for you. Sorry, I have to end it this way. There were requests by some people to have your presentation. Would you be okay with that?
Yes, madam, I will be okay with that.
So then NISTI will then forward it to the people who wanted the, right, Dr. Yadav and Dr. Lal?
Thank you, Professor
Okay.
Nian. The most cute lady.
Thank you.
Thank you.
Thank you, everybody.
Thank you. Thank
See
you,
you
Dr.
at the
Shital.
next webinar, and we'll see you more often, Shital, on our website, on our webinar.
Sure, ma'am. I will
All
be
right.
more interested and pleased to have you.
All right. See you. Bye-bye.
Okay.
We should be very happy, Nian, that she has given us a certificate. And I would suggest that she also gets testimonials from the industry for her work. My best wishes to her as well. Thank you very much.
Thank you,
Okay,
sir.
thank
Thank
you.
you very
Thank you.
much.
Okay. Namaskar. So we end